Hello and welcome, young physicists. Let me start with something relatable. Have you ever spent hours reading your textbook and felt like you've done a lot of work? Well, according to physics, maybe not. In everyday language, the word work refers to any mental or physical effort, like writing, walking, or even thinking hard during an exam. But in physics, we define work much more precisely. It's not about how tired you feel. It's about whether something actually moved because of a force. Yes, in physics, work is done only when a force causes displacement of an object. So if you're pushing against a heavy wall and it doesn't budge, no matter how hard you push, then in the world of physics, you've done zero work. Let's explore this definition more deeply. In scientific terms, we say work is said to be done only when the force applied on a body makes the body move. That is, there is a displacement of the body. Let me break that down. There are two key conditions for work to be done. First, a force must be applied, and second, that force must result in displacement of the body. If either of these conditions is missing, then the work done is zero. We'll later see how this leads us to the formula for work. Work equals force multiplied by displacement multiplied by cosine theta, where theta is the angle between the direction of force and displacement, but more on that later. Right now, just remember, no movement, no work. Let's take a classic example. Imagine a man pushing a wall with all his might. His muscles are tense, sweat is dripping, and he's using maximum effort. But what happens? The wall doesn't move, so the displacement is zero. And according to the physics definition, the work done is also zero. You might be surprised by that. After all, isn't he working hard? Well, yes, biologically he's using energy, but mechanically the wall didn't move, so no mechanical work is done. This is clearly shown in the diagram, figure 2.2, where the man is pushing the wall, but there's no motion. Let's take another example. A coolie at a railway station carrying a heavy load on his head. He stands still at the platform, waiting for the train. Is he tired? Absolutely. But is he doing any work in the physics sense? No. Why? Because the load has not moved. There is no displacement. Now, let's say the train arrives and the coolie starts walking. Now the load is being displaced, and the force due to the weight is being overcome by the coolie's movement. Now, work is being done. So, standing with a load equals zero work, but walking with the load equals positive work. This definition may seem strange at first, but it helps us understand real mechanical systems better. It's important to distinguish between biological effort and physical work. Just feeling tired isn't enough. Work depends strictly on measurable motion. When engineers design machines, or when we calculate how much energy is needed to lift an object, we're interested in force and displacement, not fatigue. This is also why machines are built to reduce effort by maximizing displacement with minimal force. Understanding the scientific definition of work lays the foundation for deeper concepts like energy, power, and efficiency, all coming up in this chapter. Let's quickly revise what we've learned today. In physics, work is defined only when a force causes displacement. If there is no displacement, no matter how strong the force, the work done is zero. Real-world examples, like pushing a wall or standing still with a load, help us see this clearly. Work is a mechanical concept, not a measure of effort or tiredness. This definition prepares us to explore how energy is transferred and how machines function efficiently. I hope you now understand how work in physics is different from how we use it in daily language. So the next time someone says, "I worked so hard today," ask them, was there any displacement? See you in the next session where we'll explore types of work, positive, negative, and zero, and how to calculate work using formulas. Till then, stay curious and keep learning physics.